Hey students, we're going to go over the vocab of the Chapter 7 review real fast. Okay, sufficient condition. This is a prerequisite. B can happen if A occurs. So with parallelograms or something, we can have parallelogram. It's a sufficient condition. I can have a parallelogram if I have opposite sides that are both congruent and parallel. And we'll get into the rest of those later, but that is an example of a sufficient condition. 7-2 is all about our triangle congruence theorems. So we've got side, triangle congruence theorem, side, triangle congruence theorem, angle, triangle congruence theorem, angle, side, triangle congruence theorem. An included angle is a known angle between two known sides. So if I have a known side here and a known side here, an included angle would be right here. So this triangle, if I had to finish it, there's only one way to finish that, and because there's only one way to finish this in these two triangles, there's only one way to finish that. That means this is a triangle congruence theorem. Which one might that be? Side, angle, side. So this, in this case, is an included known angle. An included side is a side between two known angles. So something like that, where there's only one way to finish these. Even though I don't know how long those sides are going to be, there's only one way to finish those. This is an included side. Okay, moving on. We're going to talk about 7-3. Isosceles triangle base angles. Well, in an isosceles triangle, the base angles are the ones at the bottom, if the vertex is at the top. The isosceles triangle base angle theorem says that in an isosceles triangle, base angles are congruent. So this angle is congruent to this angle. And the isosceles triangle base angle converse theorem says that the sides opposite my base angles are congruent as well. So that's what's happening here. Okay, 7-4. Overlapping figures. When two figures abide in the same place, they live in the same place. So I could have a triangle right here that could abide, it could overlap with a bigger triangle, and so these would be overlapping right here. And this in the places where the line segments would be living in the same place. Overlapping triangles are just triangles that are overlapping. And non-overlapping figures when two figures do not abide in the same place or share any components. That is a good way to think about it. What components do they share? Which line segments or angles do they share? If they share none, or if no part of them is shared, then they're non-overlapping. Okay, we're going to talk about this more in detail, but we're going to move on to 7-5. The SSA condition. Side-side angle, also known as the ambiguous case. We're going to talk more about that in a second, so I'm not going to really flush that out. Well, maybe I will. So there's many ways, there's multiple ways. If I have an angle, a side, and a second side, I could finish it like that, or using the same side, I could finish it like that. And that would be an example of why this is called the ambiguous case. Legs. In a right triangle, the two sides that are not the hypotenuse are the legs. Hypotenuse, the side opposite a right angle in a triangle. So I have a right triangle here. The side opposite the right angle, we call this hypotenuse. Hypotenuse leg condition, well, or HL condition. We call that the hypotenuse leg condition. We're going to talk about that more. In the hypotenuse leg congruence theorem, it's basically the same thing. We're going to keep talking about that. SSA, triangle congruence theorem, the capitalization of the S's really, really matters. So if I know the length of the sides and a non-included angle, then I know that the triangles are congruent. If I know the length of the sides are in the correct order. We'll talk more about that when we explore 7-5 together. 7-6 is all about tessellations. We're skipping that. We've talked about tessellations already this year. And the properties of parallelogram theorem. There's 4 of these. Oh, there's 3 of these. Sorry, I got the sufficient conditions and properties mixed up. 3, the properties of parallelogram. The first one is opposite sides are congruent. The second is opposite angles are congruent. And the third is the diagonals intersect at their midpoints. So these three things, you can kind of view these as a more thorough definition of a parallelogram. And the parallelogram symmetry theorem says that parallelograms have twofold rotation symmetry. 7.8, sufficient conditions for a parallelogram theorem. There's 4 of these. The first is one pair of sides is both parallel and congruent. 2, both pairs of opposite sides are congruent. 3, the diagonals bisect each other. And 4, both pairs of opposite angles are congruent. Okay, moving fast. And 7.9, such an angle that an exterior angle is such an angle that forms a linear pair. There should be, should have made this page a little bit bigger. An interior angle, the angle of a polygon on the inside. So if I have a triangle here, this would be an interior angle. This angle here would be an exterior angle. Exterior angle theorem says that in a triangle, the measure of an exterior angle is equal to the sum of the other 2 interior angles. So if we call this angle E, this one angle I, and angle N, then we say the measure of angle E is equal to the measure of angle I plus the measure of angle N. The exterior angle inequality. Because of this, we say that the measure of angle E is greater than the sum, the exterior angle inequality says in a triangle, the measure of the exterior angle is greater than either interior angle. And the unequal sides theorem says in a triangle, if 2 sides are not congruent, then the angles opposite them are not congruent. And the unequal angles theorem says basically the same thing. In a triangle, 2 angles that are not congruent, then the sides opposite them are not congruent. So I'm going to draw a picture. Using the unequal sides theorem, we would draw something like this. We'd say because these 2 sides are not congruent, then of course these 2 angles are not congruent. And here, this is using the unequal angles theorem. These 2 angles are not congruent, then of course these 2 sides are not congruent. Unequal sides, unequal angles theorems. Okay. 7-1 is all about drawing triangles. The main thing to think about here is that triangles have 6 data points, 3 side lengths and 3 angle measures, or 3 line segments and 3 angles. So if we squeeze a triangle, what kind of information can we get from it? We have 6 side lengths and 3 side lengths and 3 angle measures per triangle. And then we really dive in pretty quickly to our side triangle congruence theorem, which is in 7-2. The point of triangle congruence theorems is to say that I can prove that triangles are congruent to one another with less than the 6 data points that each triangle has. So I can know if I have 2 triangles and I don't know their angle measures, let's say, but I do know their side lengths, I can guarantee that these 2 triangles are congruent via the SSS triangle congruence theorem, side triangle congruence theorem. Side angle side. Another way to think about this is if I have a known side, a known angle, and a known other side, known angle, and known other side, there's only one way for me to complete both these triangles, leaving me with 2 congruent triangles. Angle, side, angle, I've got a little picture drawn here. Again, there's only one way for me to complete these lines right here, these sides, and that leaves me with 2 congruent triangles. Angle, angle, side, I've drawn another picture here. There's only one way for me to complete this. and it leaves me with two congruent triangles. And those are our triangle congruence theorems, our basic ones. Okay. Then 7-3 is proofs using triangle congruence theorems. We did this one in class. I came up with a scenario. We have two triangles that are kind of connected in a way. And what we're given is that C is the midpoint of BD and that AC is equal to line segment AC is congruent to line segment CE. I want to prove that these two triangles are congruent. I give my givens, and I've said that this angle ACB is congruent to angle DCE via the vertical angle theorem. And I've used the definition of a midpoint to infer that line segment BC is congruent to line segment CD by the definition of a midpoint. Then I've proven that these two triangles are congruent via the side angle triangle congruence theorem. Here's a list of theorems that are must-haves. You'll need to have all of them we've talked about, but this is just a quick list. Vertical angle theorem. Parallel lines imply alternate interior angle congruency. Alternate interior angles congruency imply parallel lines. All triangles congruence theorems, you should know all those. The definition of a midpoint, definition of a circle, reflexive property of congruence, CPCF, that's corresponding parts of congruent figures, and the linear pair theorem.